In the previous video, we saw how we can use the WPS feature in routers to crack the WPA key. This process is 100% guaranteed, so it should work on every WPS enabled network, and therefore if your target uses WPA or WPA2 encryption and it has WPAs enabled, then that should be the first method you try to crack the password with. If WPS was not enabled, however, we have to crack the actual WPA key. Now, we explained in previous video that in WPA, each packet is encrypted using a unique temporary key. So it's not like WEP where IVs were repeated, and once we collect a large number of data packets with the same IV, we can calculate the WEP key. In WPA, each packet is encrypted using a unique IV, and it's a temporary unique IV, so that even if we collect 1 million packets, these packets will be not useful for us because they do not contain any information that can help us determine the actual WPA key. The only packets that contain some information that can help us determine the key are the handshake packets. These are 4 packets sent when a new device or a new client connects to the target network. So for example, at your home, when your own device connects to the network, so you have the password and you connect to it, a process called a 4-way handshake happens between your device and the access point. In this process, 4 packets called the handshake packets gets transferred between those 2 devices to authenticate your device with the access point. Using AirCrackNG, we can use a word list and test each password in this word list against the handshake. So, to crack WPA encrypted networks, we need 2 things. We need to capture the handshake and a word list that contains passwords to try each password in this word list against the handshake. So to crack a WPA key, the first thing we're gonna need is to capture the handshake. We're gonna capture the handshake using AeroDumpNG, the same way that we used to use it with WEP encrypted networks. So we're gonna run AeroDump. I'm just gonna run it on everything now to get the information about my target network. And this is my target. So it's AeroDumpNG BSSID, same way we used to run it against WEP networks. At the end of the day, we're only capturing packets using AeroDumpNG, so it's doing the same job. So I'm gonna put the channel as well, and then I'm gonna write to a file, and then I'm gonna call the file test handshake, and then I'm gonna put the wireless card with monitor mode. So it's the same command we used to use when we were capturing packets for WEP networks. AeroDumpNG BSSID, we put the target access point. Channel, we put the target channel. Write, we put the name of the file that we're gonna store stuff in, and 10 is our Wi-Fi card with monitor mode. Gonna hit enter, and here we go. So we have our network now. This is a WPA encrypted network, and we have here a client connected to this network. So to capture the handshake, again, we said the handshake packets get sent every time a device connects to the target access point. So now we can just sit down and wait for a device to connect to the network. Once the device connects to the network, we're gonna capture the handshake. Or we can use something that we learned in section 1, which is the deauthentication attack. In the deauthentication attack, we were able to disassociate or disconnect any device from any network that is within our Wi-Fi range. If we do that for a very short period of time, we can disassociate this device from the network for 1 second, and then the device is going to try to connect back to the network automatically, so that even the person who is using the target device is not going to notice that, but his device will actually get disconnected and reconnected so quick that he won't notice it, but we will be able to capture the handshake packets. So again, we said the handshake gets sent every time a device connects to the target network. So what we're going to do is we're going to do a deauthentication attack the same way we did it in section 1, we're gonna disconnect this device from the network for a very short period of time, so that his system will reconnect him straight away without him noticing that, but we will be able to capture the handshake. So we're gonna just run a basic DAuth attack using AirPlay-ng. We explained this in section 1. And in section 1 we put a very large number of packets when we were disconnecting our target. Now I'm only gonna put a small number only for the authentication packets. Then we're gonna put A, the MAC address of the target access point, and then I'm gonna put C to specify the client MAC address, the MAC address of the client that we want to disconnect, and then I'm gonna put my Wi-Fi card name, which is Mon0. So AirPlay-ng DAuth, the name of the attack, for the authentication packets to this access point and disconnect this device from it. Now I'm gonna hit enter, and just so I have it's DAuth. I missed a U here. And as you can see, we captured the WPA handshake here. And my target device was this. By the way, it didn't even change in here. It didn't tell me I was disconnected, because it will show a message when I get disconnected. So I didn't get any messages to be disconnected because I was disconnected for a very short period of time. And as a result, the target person didn't even notice it. And we were able to capture the handshake, as you can see here, WPA handshake from this device. Now we can use a word list and run it against this handshake to try and determine the main WPA key. Okay, now that we've captured the handshake, all we need to do to crack the WPA key is to create a word list. A word list is just a list of words that AirCrack-ng is going to go through and try each one of these words against the handshake until it successfully determines the WPA key. So the better your word list is, the more your chances are of cracking the WPA key. If the password wasn't there in your word list file, you will not be able to determine the WPA key. Now I've attached a list of ready word lists that you can just download and use, or you can create your own word list using this video tutorial. We're going to use a tool called Crunch. It's basically just a script that you specify the characters that you want in the passwords, and it'll create all possible combinations of these passwords. So the format of the command of using Crunch is crunch minimum maximum. The minimum is the minimum number of characters of the password that you want to create. So you can say I want a minimum of 4, 5, 6, whatever you want. Maximum is the maximum number of characters in the passwords. Characters, you're going to specify the characters that are going to be used to create the passwords. So you can specify A, B, C, D, E, F, G, all the lower letters, and then you can write the capital letters. You can put numbers, you can put symbols. So here you'll specify the characters that you want. And then T is very useful if you know part of the password. It's a pattern. So for example, if you're trying to guess a password and you've seen someone type in this password, so you know, for example, it starts with an A and ends with a B. So you can use the pattern option and tell Crunch to create passwords that always start with A and end with B, and it'll put all possible combinations of the characters that you put in here. So for example, in here, in this example, we have Crunch. We're going to create passwords of minimum of 6 characters and maximum of 8 characters. And the passwords are going to be combinations of the characters 1, 2, 3, 4, 5, 6. And these symbols is going to be stored in a file called wordlist. And the pattern is this password or that are going to be created, they're always going to start with an A and they're always going to end with B. So all the passwords that you're going to see in the file are going to always start with A and end with B, and they'll have all the possible combinations of the characters you specified here between the A and the B. So let's just run it here and create a sample word list. I'm going to say crunch, and then we're going to make a minimum of 6 and maximum of 6, or let's say minimum of 4, maximum of 6. And just so that it doesn't take a long time, I'm gonna make it short. I'm gonna put the characters. So I'm gonna just put 1, 2, 3 AB. I'm gonna store this in sample word list. So Crunch is gonna create a combination of passwords, minimum of 4 characters, maximum of 6 characters, and it's gonna create all possible combinations of 1, 2, 3 AB, and it's gonna store all that in a file called sample word list. Now we can read this file. We can just say cat sample word list, and we can see all the passwords that are stored in this file now. So that's all the passwords that Crunch created for us. So you can see it was 19,375 combinations possible from only 1, 2, 3 AB. Obviously, the bigger the password that you put, the more characters you put, the more passwords that you can make, and the more space they're gonna take. So let's just have a look on the pattern option. So we'll go Crunch. Let's say a minimum of 5 and a maximum of 5. So all passwords, I want them to be 5 character long. And then I'll put the characters, which are 1, 2, 3 AB like before. And then I'm gonna add the T option, which is the pattern. And I'm gonna say I want a password start with an A and end with a B. And I want all possible combinations of my characters between the A and the B. And then we're gonna specify the output file, and let's call it pattern word list. And you can see here it's gonna create 125 passwords, and let's have a look on them. And as you can see here, it's always starting with an A and always ending with a B. So you can use Crunch now to create your word list. And in the next video, we're gonna use the word list and the handshake file to determine the actual WPA key. Now that we've captured the handshake from our target access point and we have a word list ready to use, we can use aircrack-ng to crack or determine the key for the target access point. Aircrack-ng is gonna go through the word list file. It's gonna combine each password with the name of our target access point to create a PMK. The PMK is created using a certain algorithm called the PBKDF2. So it's not like just combining the password and the ESSID. It's encrypting them in a certain way. And then it's going to compare the PMK to the handshake. If the PMK was valid, then the password that was used is the password for the target access point. If it wasn't valid, then aircrack-ng is just going to try the next password. So again, aircrack-ng is going to go through the list. It's going to combine each password in the list with the name of the target access point to create a PMK. The PMK is compared with the handshake. If the PMK is valid, then that password is the password for the target access point. If it's not, then it's just going to try the next password. All this is going to be done using aircrack-ng. Let's see how we do it. So it's going to be aircrack-ng, the name of the file that contains the handshake, and that is test handshake01.cap, and then we'll put -w and the name of the word list. So I have it called WPA word list. So aircrack-ng, test the name of the file that contains the handshake, and then we have the name of the word list after the -w. I'm gonna hit enter, and now aircrack-ng is gonna go through the list. As you can see, it's trying all the passwords. It's gonna combine each password with the name of the target access point to create a PMK, and then compare the PMK to the handshake. If the PMK is valid, then the password that was used to create the PMK is the password for the target access point. If the PMK is not, then it's just going to try the next password. And as you can see, the key was found, and that's the same key that we were able to find when we attacked it using the WPS feature. So this was the basic way, using a word list and it took 2 minutes and 16 seconds to crack the password. Now the speed depends on how quick your processor and if you have any processes running that's making your computer a bit slower. Now so far we learned how to use aircrack-ng to run a word list attack and crack the password for WPA and WPA2 networks. We did this by doing aircrack-ng followed by the file name that contains the handshake, and followed by the name of the word list, which in my case is WPA word list. Now running this command will start the cracking, and as you can see now it's going through the whole word list trying every single possible password in there. So I'm gonna Control C this, and as you can see I have a quite big dictionary in here, so it would take 2 hours and 13 minutes to go through this whole dictionary to try all the possible passwords in there. Now there are much bigger dictionaries than the one I'm using right here, so the cracking process can take several hours or even days. Now this is not bad for cracking WPA. I wouldn't mind waiting a day or two to get my password. The only problem is you're gonna have to let aircrack-ng run for this amount of time, because if you quit aircrack-ng and run the command again, as you can see we're gonna start from 0% again, and we're gonna start from the start of the file, so aircrack-ng doesn't save where it reached in the previous cracking session. So what I want to show you today is how to save the cracking session so that if you quit aircrack-ng and come back to it in a day or two, or even if you come back to it after a week, you'll still have your session and you'll start from where you left the last time. So to do this, we're gonna first of all use a tool called John the Ripper. Now John the Ripper is a very famous cracking tool that can be used to do many things. In this lecture, we're going to use it to do something very simple, which is literally just display our word list on the screen. And I'll tell you why we'll do that. So first of all, let me show you the command. It's going to be John, followed by the name of the word list. So we're going to say word list, and give it the name of my word list, which is WPA word list. And then I'm going to tell it that I want you to display this on the standard output, which is basically this current terminal screen. So the command is very simple. We're just doing John, which is the name of the program. We're giving it our word list, which is stored in the root directory, so it's the current working directory. That's why all I have to do is just give its name. And then I'm saying that I want you to display this to me on the standard output on the terminal screen. Now I'm going to hit enter. And as you can see, this command will literally just list all the passwords stored in the word list. Now I hit Control C to stop because it's a very big file and it'll take a while to list everything. But you get the idea. The command will literally just display all the passwords on screen. Now the question is, why am I doing this? Well, in Linux, we can redirect the output to anywhere we want, really. So we're going to use a very useful feature where we can redirect the output of this current command and use it as an input to another command. Now we've seen before that when we use aircrack-ng, we give it our word list as the input. Today, we're going to use the output generated by the command that we just seen, which is basically our word list, and we're going to use it as an input to aircrack-ng. And we're going to use that using the pipe character, which is the vertical bar. And then we're going to use our aircrack-ng command in here. So it's going to be aircrack-ng, followed by the -w option where we usually give our word list. But we're not going to give a word list this time. We wanted to use the output generated by the previous command. And to do that, we're just going to put a dash instead of the word list. And then we're going to fill the command as we usually do. So we're going to do -b to specify the MAC address for my target network. Now I've already copied this, so I'm just going to paste it. And then we're going to specify the name of the file that contains the handshake
and in my case it's called handshake -01.cap. So I'm gonna go over this command again just to explain it to you. So first of all, we're using the first command here that I showed you before, and this command is literally just going to display the output of the word list on screen. Then we use the bar character to pipe the output of the screen, which is basically my word list, to aircrack-ng. So we used aircrack-ng as we usually do, and the only difference in here, instead of giving a word list name, we put a dash to tell aircrack that get your word list from the result of the previous command, from the result of the pipe. Now all of this is good, but what we did so far, basically we're literally just doing something that is very similar to the normal aircrack-ng command, because this command right here displays the word list and this command right here reads it. So we still haven't stored our session. And here is why we use John the Ripper. So the only reason we use John the Ripper is not to display the output on screen. This is useless. We can do it using other programs, but we use it because it can store and resume sessions. So we're gonna add one more argument to John the Ripper, and that is the most important argument, which is called the session. So we're gonna do session, and we're gonna name it anything. So we're just gonna name it UPC because the name of my network is UPC. So now when John the Ripper will run, it's gonna read all the passwords. It's going to pipe them to aircrack-ng. Aircrack-ng is gonna read these passwords and start cracking. And then when we quit, John the Ripper will store this session in a file called UPC. So I'm gonna hit enter. And you'll see that aircrack-ng will just start as usual trying to crack my password. And I'm just gonna let this run for a little bit of time so some progress is made, and then we'll see if we're actually resuming from where we left. Okay, now I'm gonna press on the Q button to quit. And as you can see, we finished 0.4, you can think 0.39 of the whole file. So our progress is 0.39%. So our session name now is called UPC because we specified that in the session argument. So I'm gonna clear all of this. And we're gonna use John again to resume the session. So we're gonna tell it to restore. And then we're gonna give it the session name, and my session name is UPC. Then I'm gonna pipe all of this again to aircrack-ng. I'm gonna give it -w, my word list, and I'm gonna set that to dash because again I wanted to get the word list from the result of the previous command, which is the John the Ripper command. Then I'm gonna give it my BSS ID, followed by the name of the file that contains the handshake, which is handshake01.cap. Now notice this time we didn't specify a word list because basically what we're doing is we're telling John the Ripper to start from where it left last time. We gave the word list in the previous command, and now all we have to do is literally just tell John to start from where you left, and John can do that because it supports that functionality. And then we're piping whatever John is gonna read to aircrack-ng. Again, with aircrack-ng, we're not giving it the word list because it's getting it from John. Then we're giving it the BSS ID and the handshake file. Now if I hit enter, you'll see the cracking will start again, but I'm gonna stop it quickly this time just to show you that we are already at 50%. So as you can see, there is no way we could have done that in this very short period of time, which means we basically started from where we left the last time. So like I said, this method is very simple because it allows you to basically stop the attack and then come back whenever you want. Also, piping is a very handy skill to know because you can actually use it in so many scenarios to do different types of things. In the previous lecture, we covered how to store our progress when going through a large word list. This allows us to pause and resume so that we can stop our cracking session and then come back at a different time and then start the session from where we left, which is very handy when we have a large word list. Another issue that we might face when you're using a large word list is the disk space. So a large word list would basically just take a lot of space from our disk. The solution to this is to generate the word list using crunch and pass it on the fly to aircrack-ng. So basically we're going to be using crunch to create the word list like we've seen before, but instead of saving the word list on disk, we're going to make it produce the word list on screen. So the result is going to be very similar to what we got when we opened our word list with John the Ripper in the previous lecture. And then we're going to pipe that output to aircrack-ng, which will read that as input and process the word list on the fly as it's being generated on crunch. This way the word list will not be stored in a specific file and it won't take a lot of disk space. Now let me show you how to do that, and it's going to become more clear. So first of all, before I do the whole command, I'm just going to show you the command that we usually use with crunch. So we usually do crunch, and then we do the minimum number of characters followed by the maximum number of characters. And I'm going to set both to 8 because this is the minimum number of characters that you can use in a WPA password. Then we usually specify the characters to use to generate the word list. Now I'm not going to specify any characters right now because I want to use all the characters. So if I don't specify any characters, crunch will use A, B, C, D, E, F, G all the way up to Z by default. So all I have to do now is just do -O to specify the file to save the word list to, and let's just save it to all.txt. Now I'm gonna hit enter, and as you can see this file is gonna be huge. It's gonna be 1 terabyte, 1750 gigabytes, and this much megabytes. So it's gonna be a huge file, and I actually don't have enough space on my disk to store that file. So I'm gonna do Control-C, and what I'm gonna do right now is I'm gonna run the same command, and I'm just gonna omit the -O argument. So what I'm doing right now is crunch. I'm telling it that I want you to generate passwords of length 8, and I didn't specify any characters because I wanted to use all characters A to Z. Now if you want to use specific characters, you can just type them in here, A, B, C, D, E, F, G, 1, 2, 3, as I showed you before. So I'm gonna hit enter with this, and you'll see that it's still telling me that this is gonna take 1 terabyte, 1750 gigabytes, but it's displaying the result on screen. It's not storing it in a file. And if we let this run for a long period of time, it'll actually display all possible combinations of characters that have a length of 8 characters and contain the characters A to Z. Now I'm going to do Control-C to this because this is not useful for me. I'm just doing this to show you. But if you notice, the output right now is very similar to the output that I got in the previous lecture when I opened my word list using John the Ripper, when we were doing the pause and resume process. So you can see that the result is being displayed on screen for me now, which is very cool. So what I want to do right now is I want to pipe this result. So we usually pipe using this character like we've seen before. So what I want to do right now is I want to pipe the result of this command to aircrack-ng. And like I said earlier, this command is producing a result very similar to the result that we got from John in the previous lecture, which means the output right now is exactly the same output that we got from John in the previous lecture. So the command that we're going to be passing this to can be exactly the same command that we used in the previous lecture, and it should work. Therefore, all I'm going to do is I'm going to do aircrack-ng, and I'm going to give it the BSS ID of my target network. Then I'm gonna give it -w to give it the word list. And just like I did in my previous lecture, I'm gonna do a dash to tell it that use the output of the previous command as the input for the word list. Then I'm gonna give it the handshake file, which is called handshake01.cap. And that's it, I'm good to go. So we're doing a crunch 88 to generate passwords of length 8 from A to Z. And again, you can use any crunch command right here. You can use any combination, any characters, any pattern, exactly the same way that I showed you in the crunch lecture. Then we're not using a -o option because we don't want it to save anything on disk. We want the result to be displayed on screen. And then we're piping that result to aircrack-ng. Now to aircrack-ng, we're giving it, I actually should not have a space here. So we're giving it the BSS ID of the target network. We're giving it the dictionary. And we're not actually giving a name for the dictionary, we're only giving it a dash, and this is because we're telling it that I want you to use the output of the previous command as the input. So this is exactly like we did in the previous lecture. And then we're giving it the file that contains the handshake. Now if I hit enter, I misspelled aircrack, so it's like this. Now if I hit enter, and as you can see now, aircrack-ng is working. It's taking the passwords generated by crunch on the fly and using them as the dictionary. So the word list is not being stored on my disk. My disk will not get full, and this way we'll be able to use huge word lists for cracking. The only problem right now is this word list is really big, and there is no way we can go through it within one session. So it'll be great if we can save our progress and be able to stop and continue whenever we have the time. So in the next lecture, I'm going to show you how to combine what we learned in this lecture and in the previous lecture so that we can use a huge word list and use it directly with aircrack-ng without saving it on disk, and also be able to stop and resume our progress. So far we've seen how we can use piping to store our cracking progress, and we've seen how to use it to generate a word list and pipe it to aircrack-ng on the fly without storing that word list on disk, which allow us to use huge word lists that we don't even have enough space to store. Ultimately, and what I want to show you in this lecture, is how to combine both of these ideas so that we can use huge word lists without storing them on our disk, and at the same time be able to pause and resume whenever we want so we can store our cracking progress. Again, we're going to be using piping this time, and we're going to be combining everything that we learned so far. So the idea is going to be like this. First, we're going to be using crunch to create our word list. We're going to pass the word list to John, which will read the word list made by crunch, and it'll allow us to save and restore our progress. So the only reason we're using John is to be able to store the location where we reached in the word list, so that when we start the cracking again, we don't start from the start of the word list, we start from where we left. Then, since John knows where we stopped, we're going to start from there, and it's going to modify our word list. So it's going to take out, for example, the first 10,000 words that we tried already. So we're going to have a modified word list, and that's the one that we're going to be piping or passing to aircrack-ng, which will do the cracking, which will do all of the heavy work, if you want to think of it that way. So right now we're going to be combining what we learned so far, and let me show you how to do it. It'll become much more clear when we do it. So I have my terminal here, and like we said, the first thing that we want to do is to generate our word list. And again, you can use any crunch command you want, but right now I'm going to use the command that I used in my previous lecture, which is just crunch 88. Like I said before, this will generate word list of length 8, and it'll use combinations of all of the small alphabet characters. So it's A, B, C, D up to Z, all small. Now this is a very big word list, and if you want to use something custom, something different, then you can put the command here any way you want, as I showed you before in the crunch lecture. But for now, we're just going to keep it at this, because this is a big enough word list. Then we're going to use the pipe character to pipe the result of this command to John, because we said we're going to use John to allow us to store and resume our progress. So our command is going to be John. And if you remember in the lecture where we did the pause and resume, we passed a word list, an already made word list, to John. Now in this case, Crunch is making the word list for us, and it's being passed to John. So it's being passed to John as the standard input. So we're going to tell John to read the word list from the standard input. And we can do that using the std_in argument. Then we're going to give it a session name. So this is the name of our cracking session. So I'm going to do session. And let's call it session 1. Then, just like we did before in the John lecture, we want to pass all of this to aircrack_ng. So we want it to display the word list that it's going to modify on the standard output. And again, we do this using the std_out argument. Now we're generating our word list using Crunch. We're passing the result to John. And we're telling John that I want you to read this from the standard input and store all of the session in a session called session 1 and display the result on screen on std_out, so on the standard output. Then the last thing that we're going to do is pass this to aircrack_ng. So our command is going to be aircrack_ng, exactly the same command that we've been using in the previous lectures, -b to give it the BSS ID of my target. Then we're going to do -w, and we usually give the word list after this, but as we've seen in previous lectures, when we're piping the word list, we give it a dash to tell it to read the word list from the standard input. Then we give it the file that contains the handshake, and in my case it's called handshake-01.cap. So let me go through the command one more time just so that everything is clear. So the first command is crunch88, and as we've seen before, this command will display the word list on screen. So it's displaying the word list on the standard input. We put the pipe character to pipe the standard input into John. And then we tell John to read its word list from the standard input. Before we used to give John a word list, but right now I'm telling John to read your word list from the standard input. I want you to store this in a session called session 1, and I want you to display that on the standard output. So that's again displaying it on screen. Then we're piping the standard output as an input for aircrack_ng. We're given the BSS ID of my target network, and then we're telling aircrack_ng to read the word list from the standard input by giving it the dash in here, and then we're giving it the handshake file that contains my handshake. Now I'm gonna hit enter, and as you can see now, aircrack_ng starts the cracking process. It's reading the word list that's being generated by Crunch on the fly, and that word list is going to contain characters from A to Z, all small characters, and as you can see now, aircrack_ng is going through these word by word right now. Now if we do Control+C, at the same time, our progress is going to be saved. So I'm going to do Control+C, and let's see how we can restore our session and start from where we left in here. So I'm gonna clear this. So again, the first thing that we're gonna do is generate our word list, and it's gonna be crunch88. Then we're gonna pipe this to John. And we're gonna tell John this time. Last time we told it to read the word list from the standard input and then display it on the standard output. Right now we don't need to do that. All we have to do is just tell John to restore and give it the name of my session. And the name of my session was session 1. Then this will display everything on screen. So it's going to display the modified word list from this on screen. And then I'd want to pass this to aircrack-ng. And again, my aircrack-ng is going to be very similar to the aircrack-ng that I've been using. So it's going to be aircrack-ng. We're going to give it the BSS ID of my target network. We're going to give it the word list, and again we're going to use the dash to tell aircrack-ng to read the word list from the standard input, so I'm not giving it an actual file. And then we're going to give it the name of the file that contains the handshake, which is handshake01.cap. Now let me explain to you what's going to happen. So first of all, we're doing crunch 88 to generate the word list. And with this, because we wanted to keep generating the word list, because for example, let's say we reached line 10,000, we wanted to start from line 10,000. So we still have to use crunch to start from there. And then we're using John to restore our session because crunch doesn't know where we were. So using John, we're going to be starting from the line where we left off. John is going to display that on screen. And we're piping that output, so the screen is the standard output, and we're piping that output to the standard input of aircrack-ng. And aircrack-ng is catching that because we're doing -w dash, which tells aircrack-ng to read its word list from the standard input, which is being piped by John. Then we're giving it the name of the file that contains the handshake. Now if I hit enter, I should start cracking from AAAAI instead of starting from AAAA. So I'm going to hit enter. And as you can see, we are at AAAAJ, which basically J comes after I, which basically means that we restored our session. And using this method now, we can first of all restore our session, so we can stop and resume whenever we have the time. We can use huge word lists because we're not storing the word list on disk, we're generating the word list on the fly and then piping it to aircrack-ng. So with this method we can use huge word lists and we can store our progress without using too much space on our computer.
We saw in the previous video how we can use aircrack-ng to crack WPA encrypted passwords using a word list. In the previous video, aircrack-ng went through our word list. It combined each password in the word list with the ESS ID to create the PMK using the WPA2 algorithm, and then compared the PMK to the handshake. If the PMK was valid, then the password that was used to create the PMK is the password we're looking for. If it's not, it just went to the next password and created a PMK from it. So aircrack-ng was creating the PMKs on the fly. The process of combining the password and the ESS ID to create the PMK takes a good bit of time, so it takes the most time of the cracking process. Therefore, in many scenarios, while we're waiting to capture the handshake, in many scenarios we'll have access points that doesn't have any clients connected to it. So if we have something like that, we have to wait until someone connects to the access point to capture the handshake. So while we're waiting, we can actually save time by converting our word list to a PMK list. Because as I said, converting the password to a PMK takes the most time. So while we're waiting, we can change each password in the list and create a new PMK list from our word list. And then once we capture the handshake, we can use our ready PMKs, and the cracking process is going to be much quicker. We're going to do this using aerolibng. So let's see how it works. Okay, so our first command is going to be to create a new database and import our word list in that database. So it's going to be aerolibng. We're going to create a new database.
So let's call it test DB, and we're gonna import passwords, and we're gonna put the name of our word list, which is called WPA word list. So very simple. Arrowlib is the name of the program, test is the name of the database that we're gonna create, and we're telling it to import passwords, and the passwords are gonna be taken from a file called WPA word list. Gonna hit enter, and as you can see, a new database called test DB has been created, and the passwords have been imported into it. So the next command we're gonna do is we're gonna import our ESSID to the database. So I'm just gonna store the name of the ESSID of the target network into a file. I'm gonna do this using a Linux command, the echo command. So I'm just gonna say test AP. I'm gonna echo it to a file, and I'm gonna call the file test ESSID. So that's basically, so I'm gonna read it now. Cat test ESSID. That's just making sure that the name is there. So this command, I just created a file and I saved the word test AP in that file. That's the name of my target access point. And then here I just read the file to make sure that it actually contains test AP, and we can see that it contains test AP. Now I'm going to import this file into my database. So we're going to use the same command that we used before. The only difference is we're going to say we're importing ESSID this time, and the name of the file that contains the ESSIDs is test ESSID. So again, arrowlib-ng test DB, that's the name of my database that I'm importing information to. Import is the command, we want to import stuff. ESSID is the name that we're telling it we want to import ESSID. And test ESSID is just a text file that contains the name of my target access point. Gonna hit enter, and that has been imported successfully. Now this is the step that takes the most time. We're gonna convert each password in the list. We're gonna combine it with the ESSID. So we're gonna create a list of PMKs from our word list. Again, we're gonna use arrowlib-ng, and we're gonna put the name of the database that contains our word list, and then we're gonna tell it to batch, which is just convert each password, combine it with the ESSID, and create a PMK from each password in the list. Okay, so as you can see now, it computed all the PMKs, so that's the number of PMKs, that's the number of passwords that I have in my original list, and all of these passwords have been converted to PMKs, and they're stored in my database, which is testdb. And we can see that it took 366 seconds. So we're saving this time because in the scenario that we're working on, we'd be only waiting for the handshake. So we can do this while we're waiting to capture the handshake. Once we have the handshake, then we can crack it straight away using the PMKs, the already done PMKs, which will be much quicker. Let's see how we do that. We're gonna use arcrackng, and we're gonna use the option R to specify our database, which is called testdb. And then we're gonna specify our handshake file, which is WPA or test handshake.cap. So very simple, arcrackng R to specify the testdb, and then we're gonna specify the handshake file. Gonna hit enter, and as you can see, we cracked the password in much quicker. We cracked it in less than a second. So in the previous video it took 2 minutes and 16 seconds. Now it took less than 1 second. So it's much quicker because instead of arcrackng converting each password to a PMK, we are using a list of already made PMKs. So this is useful if we are if capturing the handshake is taking a while because there is no clients connected to the target network. We have our PMKs ready so that once we capture the handshake, we can crack it straight away. Now every time we use aircrack-ng, regardless of the method, aircrack-ng will use the CPU or the central processing unit to process the passwords and try them against the handshake. So basically the processor or the CPU is what's being used in the cracking process. Now this is usually the default behavior of most tools because the CPU is the brains of the computer, it's the central processing unit, and thus the default component that's used when the computer needs to process data. Now, if we pause for a second and think, a lot of computers also contain another processing unit, which is the GPU. The GPU stands for the graphics processing unit, and it's built and designed so that they can carry out repetitive tasks very quickly. For example, rendering pixels on the screen is a very repetitive task because it literally loops over each pixel on screen and displays data in it. Therefore, the process of key cracking is very similar in its essence to rendering pixels on screen, for example. Basically, it's a very repetitive task because we go through the word list and we take each password in the word list and then try to test it against the handshake and see if it's valid or not. So it's a very repetitive task, and because the GPUs are optimized to carry out repetitive tasks very quickly, they're actually more efficient than CPUs when it comes to cracking. So, if you have a good graphics card, you can use that graphic card or GPU in the cracking process instead of the CPU, and that way you'll be able to go through the word list and carry out the cracking process much faster than if you would do it with the CPU. And that's the main goal of this lecture. I want to show you how to use the GPU in the cracking process instead of the CPU, and we'll see how fast that is compared to the speed that we were getting with the CPU. Now first of all, before we do anything, you need to have a powerful GPU or at least a good graphics card. We're going to use a tool called Hashcat for the cracking process because aircrack-ng does not allow us to use the graphics card in the cracking. I'm also going to do this from a Windows machine because most GPUs have drivers for Windows and it'll be very difficult to install their drivers for Linux. So if you can install your driver for Linux, then it's okay. You can use Hashcat from Linux exactly the same way that I'm going to show it in this video, but I'm showing you how to do it from Windows because it's actually much easier to install the drivers for graphics card for Windows because most manufacturers release official drivers for Windows, whereas when you go to Linux, you might have to install third-party packages to get it to work. So I have the website here for Hashcat. I'm going to include it in the resources. Now before you can use Hashcat, you'll have to download the driver requirements for your GPU. So you can see in here we have a list of the drivers that you need to download. So if you have an AMD GPU, you'll need to download the AMD Radeon software. For Linux, you'll have to download the AMD GPU Pro driver, and so on. Now I'm on Windows, so I'm just gonna highlight this and I'm gonna right click and search Google for it. Now you'll see the first result will come up with the right result, so I'm just gonna click it. And then you can see I can download it from here. Installing it is very easy. Just double click the downloaded file, then next, and then your computer will restart and you'll have it installed. Now I've already done all of that, so I'm going to go back to Hashcat and I'm going to go ahead and download the binary of Hashcat. And as you can see now, that's downloaded for me and it's gone in the downloads directory. So it's a zipped file, it's a 7-zip file. You'll need an archive manager to open it. I already have WinRAR installed, so I'm just going to double click it and that's going to be opened in WinRAR. Now I'm gonna click its directory here, click on extract to uncompress it, and I'm gonna choose to uncompress it in my C directory. I'm gonna hit OK, and that'll basically put the files for Hashcat in my C directory. Now the next step is gonna be converting my handshake to a file that's compatible with Hashcat. Now, when we capture the handshake, as we've seen in all the previous lectures, it's usually stored in a file that has a cap extension, so .cap. Now hashcat can't read the .cap files, so we'll have to convert this to a file that's compatible with hashcat. Now we can do that very easily using an online tool made by hashcat. So I have it right here, and again I'm going to include its link in the resources. Now all you'll have to do is just go on choose file, choose the cap file that contains the handshake, click on open, and then put the network name in the ESSID field. Now my network name is already stored in there, so it's UPC 723.762. I'm gonna click on convert. Now as you can see, now this automatically changed the file type to a HCCAPX file, and it automatically downloaded it for me as well. So if I go to my downloads directory, you can see that I have a new file here, and it has a HCCAPX extension. This is the extension that hashcat can read and understand. Now I'm just going to rename this file, and I'm going to call it handshake so that it's easier for us to know. Now we're all set. I have my handshake here, and I also have my word list right here, which is called ROQ. And I'm just going to copy both of these files and put them in the same directory as hashcat. So I put hashcat in C, so it's in my PC, C, and it's called hashcat. And I'm going to paste the word list and the handshake in here. Now we're all set. We have our word list and the handshake on the same directory as hashcat binary. So now we're ready to use hashcat, and all we have to do is we have to navigate here from Windows command prompt and then run hashcat against this handshake with the dictionary that we just copied. So in the next lecture, I'm going to show you how to use hashcat from the Windows command prompt to crack the handshake using the GPU instead of the CPU. Alright, now that we have everything ready, I have hashcat already extracted in here, I have my handshake and my word list, so I'm ready to use hashcat to crack the password. So first of all, we have to open the command prompt. So I'm going to go to the start menu. I'm going to type CMD to access my command prompt. Now I'm going to navigate to the location where I extracted hashcat. So it was in C. So what I'm going to do is I'm going to do CD / to go all the way back to the root of the C directory. Then I'm going to do dir to list all available directories. This is the equivalent to ls in Linux. And as you can see now, I have a directory called hashcat. So I want to navigate into that. And to do that, we're going to do cd hashcat, and I'm going to press tab to autocomplete. And then I'm going to do dir again to list all the files in this current directory. And as you can see, I have hashcat binaries in here. I have a 32-bit and a 64-bit binary. So you need to run the one that's compatible with your processor. And you can see I also have my handshake that I copied earlier. And I have my word list right there. Now to run hashcat, we're going to do hashcat 64.exe, and I'm going to do -- help to see all the options and arguments that I can use with the tool. And as you can see, we get a big list that show us all the options and how to exactly use the tool. So at the top here, you can see the usage of the tool. So this is the default syntax that you should use the tool with. And this is exactly the same whether you use the tool from Linux or from Windows. So I'm showing you how to use it from Windows, but if you manage to install your graphics card drivers on your Linux, then you can use it the same way that I'm showing you here. So basically you need to give the tool name at the start, which is hashcat. Then we're going to set the options, and you can see we have a big list of options here at the bottom. Then you're going to give the file that contains the data that you want to crack, and in our case it's the HCCAPX file, followed by the dictionary to run the attack, and in our case it's going to be called ROQ. So I'm gonna type in hashcat. Now because I'm on Windows, I'm gonna have to type hashcat64.exe, but if you're on Linux, you're just gonna do hashcat. Then we're gonna have to set the options. And as you can see, we have a huge list of options that we can set. For each option, we can see the option name. We can see the type, so this is the value that this option can take. It can be a number, it could be a file, it could be a character. We can see the description, so this tells us what we can set with this option. And then we have an example at the end showing us an example of setting this option to a certain value. Now the first option or argument that I want to use is the -I. And in the description, you can see that this argument will show us information about the devices in this computer that can be used for cracking. So if we just do -I, you can see that we have two devices that we can use for cracking. We have my device number 1, which is the GPU, and it has an ID of 1, and you can see all the information about this device in here, including its memory. Then we can see we have another device, and that is a CPU, it's not a GPU. And again, you can see all the information related to this device. Now the next option that I want to use is the -M. Now this specifies the hash type, so the type of hash that you want to crack. Now the hash type is a number, so we have to give a number that corresponds to the hash that we want to crack. And if we scroll down, you'll see that we have a table called hash modes, and it contains all the hashes that we can crack and their corresponding number. So my target is a WPA hash or WPA2, and you can see that the number corresponding to this is 2500. So to set this option, we're going to do -M, and we're going to put 2500 to tell hashcat that I want to crack a WPA or WPA2 hash. Now the next option that I want to set is the -D to tell hashcat which device I want to use for cracking. So when we did -I, we seen we had two devices. We had number 1, which was my GPU, and we had number 2, which was my CPU. So I want to use the GPU for cracking, and therefore I'm going to do -D1. Now let's go up and have another look on the usage of the tool to make sure that we're using it properly. So we've already set hashcat, we've already set the options, and the next thing that we need to do is to give the capx file followed by the wordlist file. So we've already converted our handshake to the hccapx extension, and we placed it with the wordlist both in the same directory as hashcat, so that's our current working directory. As you can see here, I have my wordlist and I have my hccap file right here. So my handshake is called handshake.hccapx, and my word list is called rawq.txt. So now our command is done, and let me go over it just one more time so that it's clear to you. First of all, we put the tool name, which is hashcat, and we put 64 because I have a 64-bit processor. So we're doing hashcat64.exe. We're doing -M to specify the hash type, and I'm putting 2500 because we went on the hash modes table and we seen that 2500 is the number for WPA and WPA2 hashes. Then I did -D and I put number 1 to tell hashcat that I want to use device number 1 for cracking. That's my GPU, and I was able to see all my devices by doing hashcat-I. So we did that at the start, and we seen the list, and then we seen that device number 1 corresponds to my GPU. Then according to the usage of the tool, we seen that we have to specify the handshake file after that, and I've already converted my handshake file to a hccapx extension, and it's already in the same working directory. That's why I don't need to give a full path, and it's called handshake.hccapx. And finally, we have to give the word list, and again the word list in the same working directory, so I don't have to give a full path, and we just had to say rocku.txt, which is the name of my word list. Now I'm gonna hit enter, and Hashcat is gonna start the cracking process using my GPU instead of the CPU. Now as you can see, we can actually pause and resume using the P and R if we want, and this way we'll be able to save our progress so that we can stop and come back to the cracking whenever we want. Okay, now as you can see, Hashcat is done, and it managed to get the password for me, and this is the network name, so that's the name of my network, and you can see that it managed to get me the password, which is 1234 ABCD. It took it 1 minute and 7 seconds to get to this password, and I've actually moved the password manually to the end of the word list to make sure that we go through the whole word list in this lecture. Now let me show you how big the word list is. It's actually not a small word list, it's not a huge word list, but it's big enough. So 1 minute and 7 seconds, it's a really good time to go through this word list. So I'm just gonna open it right here, and I'm gonna scroll all the way down. And as you can see, we managed to go through about 14 million passwords within 1 minute 7 seconds. Now my password is actually at the bottom, but it's not the very last password, so it's around the 14 million. But this is a very impressive time compared to the time that you'd get with the CPU. Again, 14 million passwords within 1 minute 7 seconds. Now I'm not using the best GPU in the market, so if you have a better GPU, then you'll be even faster than this. But even with that, it's a very good time. So as you can see, using the GPU will make the cracking process much faster than what it would be if we're using a CPU, even if your CPU is very fast. Now just as an idea, or for something for you to try as practice, you can actually pipe crunch to Hashcat exactly the same way that I showed you how to do it with aircrack. So you can practice that yourself, and Hashcat already supports pause and resume, so you'll be able to use huge word lists, you'll be able to save your progress, and you'll also be using your GPU for the cracking, so you'll be able to go through the word list much faster than what you would if you're using aircrack ng.